In this recording, I want to get a start on Unit 2. And we're moving along quickly here, but I think that Lightbot has really saved us some grief. Hopefully by this time you have your virtual machines running. If not, I'm going to try to limit this to a half an hour or so, and that'll give us 10-15 minutes for me to clear up any issues some of you may be having. So in the meantime, I'm going to sit back and watch. If you're not having if you're not getting Visual Studio and those kinds of things running like I do when I get started here. I'm in the Unit 2 notes. If you brought your notes with you, you want to flip to page or to Unit 2. Should have those pink dividers in there, by the way. Those of you that ordered notes, I'm expecting them to show up tomorrow. I ordered them today, but then they had their power outage in Rapids today, so maybe tomorrow. So if you don't have any notes yet, maybe tomorrow. I'll email you. And remember, if you ordered them, I expect you to pick them up. In the meantime, they're available on my website. So I'm at the top of Unit 2. Intro to Program Development. One thing that's coming down the pike, not too far down the road, is the first assignment, the worksheet. In order to do that worksheet, you'll need Microsoft Office, Word, or one of those clones that I talked about. When's it due? I don't know yet. I don't assign any programs or any worksheets until I finish the lecture. And when I looked at the notes, there was lots of pages, right? 37 pages of lecture. So that's going to take a little while. But it doesn't mean that you can't get started on that worksheet. Doesn't mean that you can't get started on the reading. Maybe somewhere around page 14. Looks like it goes up to 41, 50. 60, I don't know if we're going to get to all of those, but there's a lot of reading there. Remember, all the answers, most of the answers for the worksheets are in the book. So you can start on that. You don't have to finish it today. We don't even have a due date, and when we do have a due date, it's typically a week later. So don't sweat it. What happens if you get it done? Ship it to me, and I'll grade it. So in addition to all this lecture, there's a fair amount of book reading that you might consider doing. Okay, all the way out, probably first almost 100 pages or so. So what are we going to learn to do in this unit? In this unit, we're going to learn to create a computer program. What's bizarre, in a way, is that in order to create a program, you need a program. Bottom line. To create a program, you need a program because none of us speak the language of computers. What's the language of computers? They teach you that in networking yet? Binary. Ones and zeros, on and off. Remember, computers is stupid. All they know is on, literally all they know is on and off. Now, in the last year when I was in the other building, we had 4 light switches on the wall over there. Then we have 4. There's 2 back there. There's 2 back there. How many different ways can I flip those switches? All of them down, all of them up. This one down, this one up. This 8 different ways. No. 2 to the 4th, 16 different ways. Those light switches can be flipped. Right. Now computers have lots and lots of bytes. We talked about the other day, right? Trillions of bytes where each byte is 8 light switches. So that's 8 trillion bits. If I had that many, how many different ways can I put them? Oh, never mind. Right. Infinite number of ways to flip those switches. And computers translate those switches into letters, into numbers, into commands, even into pixels that make pictures. Magic. It's all a bunch of ones and zeros. That's all it is, behind the scenes. But you and I don't talk that language. What combination of ones and zeros would you put in to create a program that asks some or just displays hello world? I don't know. I honestly don't. I have never worked in binary. I don't need to because there are programming languages that do it for me. There are all kinds of programming languages. COBOL. I think, Paul, you told me that's what you worked in, right? And CN. Good. So COBOL, RPG, those are kind of older languages nowadays, still around. Some of them are trying to update themselves to make themselves modern and making a fiasco out of it is what I hear, but that's my opinion. Visual Basic, Java, PHP, Perl, C++, and our friend C#. In this class, we're going to use a language called C#. It's a Microsoft product to learn how to program. You're also learning C#. It's a language. When you learned English, you learned subjects and you learned verbs and adverbs and all those. Are there subjects and verbs and stuff in other languages? Sure. So once you learn the structure of things, learning a different language isn't quite so bad. Sarah?
So a group of programmers made up these languages?
Yes. What's COBOL rating? What's really bizarre, this is one of my favorite languages here, C++. A bunch of programmers once upon a time sat down and created a set of, I'm making up numbers here, 32 commands that they translated into ones and zeros so that the computer could execute those commands. It's a foundation, 32 commands. And then using those, they created more commands. Like with Lightbot, he doesn't have a turn around command. Well, couldn't I take the turn left command and tack two of them together and say, from now on, Lightbot, when I say turn around, I want you to do that. Sure. That's what they did with C++. It's called pulling yourself up by your bootstraps, bootstrapping. They started with 32 commands, and then using those 32, they built more and more and more until now C++ and C# is based on C++. Languages keep progressing and getting bigger and bigger and knowing how to do more and more things. Go ahead. Who started all this? Started in the 50s. There were some engineers for the most part. Actually, it can even go back further depending on how far in history you want to go with abacuses and all those kinds of things. But in the 50s, some of the first computers came out. First computers, I happen to know because one of the people who worked on it was Admiral Grace Hopper was her name, but she wasn't alone. There were others. Their computer would have filled this room, and every time they needed to reprogram it, they pulled out these plugs, and they had to put the plugs in different orders. How'd they figure that out? Magic, they're geniuses. I don't know. What's behind all that stuff? I don't know. It's the magic of the electronics is well over my head, and we don't really have to know either. All we have to know is I want to write a computer program. Volker said we're going to use Visual Studio and the C# component of it, and we can write programs. There are other ways to write programs. You'll learn them as you stick around here a little bit longer. But Visual Studio is one of the most common development environments. What we're going to do is define an algorithm. An algorithm is a fixed set of steps. I gave you an algorithm for creating a personal account on this computer, and you followed it, and it worked. You're going to design your own algorithms that convert our thought process, what I want the computer to do, into a fixed set of steps. But computers don't understand this. All they understand is ones and zeros. So what we need is a compiler. What's a compiler? It's a computer program that somebody wrote. We will be using a C# compiler. It is a compiler that translates C# commands that you and I type into ones and zeros. Not only does it translate them, it optimizes them. It looks at your code and says, okay, I understand what you're doing, but I actually know a quicker way to make that happen. Most compilers today are optimizing compilers. They not only look at your code and translate it, but they improve it behind the scenes without you ever having to see it. Well, shouldn't they just tell us, why don't you fix this? No. Because I'm not interested in optimized code. What am I interested in? I've said it a couple of times already. Who's paying attention?
Does it work?
I'm interested, does it work? But what am I even more? That's first. But then what? Is it maintainable? Can you or somebody else look at that code later and say, I need to fix it, or I need to enhance it, give it a new feature? I understand where I need to plug that in. If it's written efficiently, that may not be as easy to do. I'm not interested in efficiency. I don't have to be anymore because the compilers do it for me. I'm interested in writing code that's maintainable. The compiler would optimize it better than I ever could, probably. When you go work for Skyward or Berkshire Hathaway or Consolidated Consulting or whoever. They're interested in you generating as much computer code that works as you can in the quickest amount of time that you can. Programming languages help that, but it has to be maintainable because very few programs are written from scratch. If you go to work for Skyward, you're not writing anything new. If you go to work for Sentry, you're not writing anything new. Rarely, occasionally. Now with mobile applications, web applications, there's some new stuff. But Skyward is all web-based already. When you go there, some teacher or somebody said, can you make the program do this? And the answer is always yes, for the right fee, or if it's worthwhile and everybody wants it, we'll add it. Or somebody discovers a flaw in your program. Somebody needs to fix it. The person who programmed it originally probably was rewarded and promoted and they're long gone. It's your job. And there's one thing worse than fixing somebody's unmaintainable program. And that's maintaining your own, fixing your own when it's not written in a maintainable way, because then you got nobody to blame but yourself. So that's our goal here. Yes, the programs have to work. But what I'm going to be teaching you to write is maintainable code, so that after you get promoted for doing such a good job, the person who comes along behind you can look at your code, understand what it does, repair it, fix it, enhance it as needed. That's what we're shooting for. But compilers' jobs are to take the code that we write, that we can understand, that are visual to us, that are, with training, understandable for you, and turn them into ones and zeros so the computer can process. Computers can only process ones and zeros. That's it. But I'm using a word processor. I'm typing paragraphs. I'm throwing all those paragraphs, all the commands to make paragraphs, all the letters, all the pictures, all the whatever you've got in that document are translated into ones and zeros. And the next time you open that document, the ones and zeros get displayed on the screen in just the right way so it looks like words and pictures and documents. Magic. Cool stuff. Many compilers also come developed packaged with other tools. Need some way to type commands in, right? Got to be able to save those, bring them back in again. If there's errors in my program, some of them can be very complex. We use a special feature of most compilers called debuggers that help us go in and watch the code line by line by line. If your Lightbot didn't work, it would be really nice if you could say, just do this first command, then the next command, then the next command, until it next. We can do that with debuggers, and you can watch what he's doing. Oh, that's right there. There's the problem. I'll show you how to use debuggers. Back in my day, I was learning this 40 years ago. We had one compiler, that was a separate program. We typed the program over here. If we needed debugger help, we had to launch another program and the debugger kicked in. And then there was a help system, and that was separate. And this was after I stopped using punch cards. I've been around that long. Paul's back there nodding. Use punch cards? Mm-hmm. Those are terrible. Because you make a typing mistake, it's punching holes in the card. You make a typing mistake, you throw the card away and start over. There's no putting the hole back. Those are terrible. I was glad my senior year when they took those away from us, said, here, use this computer and save it in a file. And if you make a mistake, backspace it and fix it. That's nice, thank you. Made life a whole lot easier. But we needed separate programs to do all those things, and that was painful. Now they're all combined together into something called an IDE, and it's not there, but it'll probably show up later, Integrated Development Environment. Everything you need to write programs in one handy-dandy 5 gigabyte package nowadays. They're huge. Tons and tons of stuff in there that supposedly make your job easier, makes it easier to work in a team, makes it easier to do all the stuff that we do for program development. Sad news is, for most of us, we don't need but a fraction of that. That's okay, because it's free. I'll take the extra stuff and ignore it. Once upon a time, there were procedural languages. They still exist, like COBOL, RPG. Today, most of those have been replaced by object-oriented languages. Objects are things. We don't write code by typing lines all the time anymore. Now, we can start doing a little more like in Star Trek, where Spock says, I need to reconfigure the warp core, and he drags this and drags that and drags this, and all of a sudden the ship goes faster. He's reprogrammed it just by dragging stuff around and putting it together in different ways. We're doing more of that. I need a text box. I need a radio button. You just drag one. The computer commands to create a circle that looks like a 3D radio button are horrendous. They're built into the language now. I don't have to write them anymore. Somebody at Microsoft said, we'd use a lot of radio buttons. Let's just make a function or a method that generates a radio button, plug it into the language, make it a feature of the language. Whenever a programmer wants one, they just ask for it. It's too cool. All been built for us. The way you program is completely different than the way we did in procedural programming once upon a time. Here we talked about code. Here we focus on objects. The other difference between these two is in a procedural language, the computer was in control. The computer said, you got to do this, and then you got to do this, and then you got to do this, and you got to do this. Imagine filling out a form where you go first name, last name, address, and you go, oh, my first name's wrong, I got to go fix that. And you can't go back. Wouldn't that be a pain? It's hard for you to imagine because you haven't seen anything like that. It's just easy. You click around wherever you want to go, right? You want to be weird and put your phone number in, then your last name, then your first name, then your city, then your street? Do it. Doesn't matter. Procedural languages, they were in control. You got to give me this first. It's still blank. Come on, you got to give me this first. It's still blank. Come on, you got to give me this. Thank you. Then you move on to the next one. And no, there's probably no going back. With procedural, object-oriented languages, you, the user, or the person who's using your computer, is more in control of what's going on. They can do things in any sequence they want. Very handy. Objects are things. Most object-oriented languages today come with many, many, many predefined objects. Radio buttons, text boxes, command buttons, anything you might want to put in a program to communicate with the user, probably already there. If you don't like theirs, you can customize them. Each of those objects has attributes or properties. It's a text box that I type text in. How wide do you want that to be? This wide? That wide? How tall? What kind of font do you want in there? Do you want a yellow background or a white background? All kinds of things that we can control without writing any code or by writing code. Either way. You'll see what I mean as we get into this a little bit more. All those objects, like buttons, also have behaviors. Things that they know how to do. If you go to a web form, I don't know if we can go to a web form. Here. I typed letters, they showed up. Oh, first of all, that's not easy. Used to be. Now it's not easy because if I change the font of my email, it changes. What happens when I hit the backspace key? It backs up. Arrow keys, it moves around. How does it know how to do that? It's built into the object. It's a behavior. When you press arrow keys, it knows how to behave. Oh, it highlighted. Cool. I don't know. Magic. We don't have to write code to do that anymore. It's built in. Text boxes all allow you to highlight, all allow you to press the end key to go to the end, unless you're on a Mac. That doesn't work. But control right arrow key to move to the end. They all know how to do that already. We don't have to teach them how. You are so lucky. They have built-in methods. They respond to events. When I drag over the top of a text box, it turns it a different color. When I click on a button, it pushes in and pushes out. When I click on a radio button, the little black ball fills in and the other ones turn off automatically. All this stuff is built into these objects by default. But even an object is built from code. Everything is code. Everything ultimately is ones and zeros. In the very near future, you will learn to use a class. A class is code that is written to do something, to represent something usually. Here's a radio button class. And you'll learn next semester how to define your own classes. I need something that describes a student. They have a first name, they have a last name, they have an age, they have a shoe size. Whatever you want that class to be, you get to define. You get to define your own. describe your own objects. That's in the future. The program that we're going to use is called Microsoft Visual Studio. It's a very mature product. It's been around for a very long time, as in 15 some odd years at least. We're using the latest and greatest edition, 2013. From my perspective, it's no different than 12, but when you come to the tech college, you don't want to be using the 12 edition when the 13 is available, even if they aren't much different. So we're using 13. It's not affecting us much. It's a piece of software. It's a program. You're going to download it from the web. You're going to install it on your computer, and it will help you write programs. It is a program designed to write programs. It's pretty much its only purpose in life. It's for programmers. That's why I'm not worried about you sharing it with all your friends, because what would they do with it? Unless you train them to write programs, and trust me, they're probably not interested. Comes with an editor, so we can type to our heart's content. That editor is smart. It knows things. It changes the color of things based on whether it's part of the language or it's something you dreamed up. It uses color coding to help you sense errors ahead of time. It knows about all the things that are built into the language, so that when you type text, it gives you a list of everything it knows about that starts with the letters text, and you don't have to type the rest. You just pick it from the list, and those of you who don't type very well, this is a godsend. It's called IntelliSense. It senses what you're typing, makes suggestions, and you pick from the list. I'll show you how to use it. All of that comes with a debugger and a help system and that most important compiler that turns the programs that you write into ones and zeros so that your computer can execute them. All in one handy dandy little package called an IDE. Not little, now it's big. C# runs the Microsoft.NET framework. I think the latest edition is still 4.5. The framework is a library of pre-built objects, text boxes, radio buttons, everything you can dream up, already predefined. What's really amazing is because of the framework, when you write a program, let's say you create it in Windows 7, then you take it home and you run it on your Windows 8 machine, it changes because it just draws what's the buttons look like, what do the buttons look like in Windows 8? They're a little different than they are in Windows 7, but it goes out to the framework and said, I need to know what a button looks like, please, and it puts the new ones in. So as you update your operating system, it automatically updates the look of your program. Magic. Don't go to 8 if you don't want that then. It's not what?
It seems too easy.
It seems too easy, exactly. You should have been writing programs when I had to learn how to do this, but it's still not easy. There's plenty to it. There's a lot of things it doesn't know how to do that otherwise, why would we be here? If it knows how to do everything, we don't need to write code. A lot of pre-written code, common utilities for doing math. If you need to do natural logarithms, I don't even know what they mean, but if somebody gives me an equation that says you need one, I can translate it and tell C# to do a natural logarithm. String manipulation, all kinds of stuff. Okay. Let's quit yakking for a little bit and do something. For those of you who've got your virtual machines running, on the Start menu, you should see Visual Studio either here. If it's not here, click All Programs, and you should see Visual Studio 2013 here, and it's this big purple, that's an infinity sign, it's supposed to be infinitely powerful. Launch it. This is the way you start new projects, sometimes. Often, you'll have existing projects and you need to launch them later on, not today, we're not going to have time. So on Wednesday, I will show you how to launch an existing project. It's much easier. If it asks you to sign in, if you have a Microsoft Hotmail account, or I think you might be able to, we'll test this some other day, not today, but you might be able to sign into this using your Microsoft account, your Microsoft email account. Should work. It's a Microsoft account. Be interesting. We'll test it next time. For right now, we're going to go no. Supposedly, if you sign in, Visual Studio will remember you, and when you go home, any changes you've made to the Visual Studio environment itself will follow you. We're not going to make that many changes. It's going to matter that much. I would recommend the blue or the light, the themes, you can change them later and leave the development settings to general. In the future, it'll quit asking you. And start. And I should have anticipated this and had it all set up for you already, so I'm going to go into the virtual machines for next year's class. Of course, I'll probably be using 2015 by then. But this is a one-time bad deal. It'll also happen to you at home. So it's a good time to pause the recording. All right, that took a couple of minutes. I paused the recording. And once Visual Studio starts, this is what it looks like. It's got a menu, it's got a toolbar, and it goes to the start page. And from here, you can create a new project or you can open an existing one. Recent projects will be down here. That's all well and good, but I hardly ever use this start page. Whenever you're ready, you can close that start page. And now you're ready to create projects from here. So let's see what I'm supposed to talk about in my notes. When you first start a bunch of stuff, then you see the start page. When you're ready, you can close the start page. If you ever need it back again, you can go view start page. These menus are huge. I am glad that Visual Studio has not adopted all this ribbon stuff that the rest of the Microsoft products have, because I think it would just be overwhelming. We don't need the menu very often. That's the good news. When we come back on Wednesday, I will show you how to customize this toolbar to do just what we want it to do. If you're lost, don't worry about it. I'll come help you in a second. If we want to start a new project, we could have, if I hadn't closed it, on the start page, click New Project. And I think this is where I'm going to stop, because there's some important things here, and I don't want to put it into the last minute of 2 hours, so we'll make it one of the first things that we worry about on Wednesday. How do we create a new project? A project is a program. Actually, in Visual Studio, we'll see a little later, a solution is a program. A solution can contain many projects. A project can contain many forms. But in our case, we're going to have one form and one project and one solution. They're all just the same thing, layered deeper. Visual Studio is very powerful. It's designed for professional developers who have to create very complex things. A solution can include C# programs and Visual Basic programs and J# programs and images and all kinds of stuff in a solution. Way over our head. Even next semester, way over our head. It's not what we use Visual Studio for. But you still have to understand that structure, and that's also stuff we'll talk about on Tuesday.